Good morning, students. Today we'll start with the model 3 of the control system, that is time response of a control system. So before going to see in detail about the model, right, we should know the definition of time response of a control system first. Okay. So the response given by the system, which is a function of time to the applied excitation, is called time response of control system. I'll repeat, the response given by the system, which is a function of time to the applied excitation, is called time response of the control system. For example, consider an emitter, right? It is connected to measure a current of magnitude 5 ampere. Okay, so emitter pointer must deflect so as to show the 5 ampere reading on it. Okay, so 5 ampere is its ideal value that it must show there. Now the pointer will take some finite time to stabilize to indicate some reading, and after stabilizing also it depends on the various factors like friction, pointer, inertia, right? So whether it will show us accurate 5 or not. Okay, so this is one example. Or else you are an engineering student, right? It will consist of 8 semesters. Okay, so it will undergo more than 7 semesters to complete your degree, right? The response of all the semester to complete your degree, right, will be compared with the time response of the control system here. Okay, so in the first semester you may get 60%, in the second semester you may get 30%, right? In the fourth semester again 70%, like this. So this is the response, right? The response to reach, right? So I'll repeat here, the output variation during the time it takes to achieve its final value is called transient response. Transient response. So what is transient response? The output variation during the time it takes to achieve its final value is called transient response. Okay, or else the time required to achieve final value is called transient period. Okay, the time required to achieve final value is called transient response, transient period. For example, so engineering degrees of 8 semesters. Okay, the result variation during 8 semester to complete your degree is a transient response. Okay, for example, or the time required, that is 4 years time required to complete degree, is nothing but a transient period. Like this we can compare. Okay, the transient response, may be exponential, or it may be oscillatory in nature. So symbolically the transient response can be represented as Ct of t. Transient response can be represented as Ct of t. So mathematically, for stable operating system, it is given by limit t tends to infinity, Ct of t is equals to 0. Mathematically, it is given by limit t tends to infinity, Ct of t is equals to 0. So hope now we are clear with time response, transient response. Okay, now coming to the third point, steady state response. You can read it as steady or steady state response. Okay, so it is the part of the time response, which remains after complete transient response vanishes from the system output. It is part of the time response which remains after complete transient response vanishes from the system output. Okay, so such response is referred as steady state response. Okay, the steady state response indicates the accuracy of the system. The symbol for the steady state output is C of t. Okay, sorry, steady state CSS of t. The symbol to represent steady state response is CSS of t. Hence the total time response C of t, total time response is represented by C of t is equals to CSS of t plus CT of t. The total time response is represented by C of t, that is equals to CSS of t plus CT of t. So mathematically CSS of t is nothing but, that is steady state response. CT of t is nothing but transient response. Okay, or the transient response. That means mathematically the total time response C of t is a sum of steady state response plus transient response. Okay, so after this we should know what do you mean by steady state error. We should know what do you mean by a steady state error. Steady state error. Okay, so let us consider step input. Let us consider, already we have studied in S&S, so which is represented by the total response C of t. Okay, so let us consider this is the step input. Okay, you know what do you mean by step input. So this is the output response, this is the actual output response. Okay, so here I'll define this is a transient response. Transient response. Okay, so this is, after this is steady state system. Steady state of the system. Okay, so this is a total response CT of t. CT of t. So this is the actual, right? So the transient response is the one, it is the response taken to reach its final value. Okay, so that I have referred as, up to this I have referred as transient response. Again it will be in terms of time only. So this is CT of t. Okay, this is CSS of t. Yes or no? Or else you can here also represent this is nothing but CSS of t. Okay, so the difference between the desired output, this is the desired output, this is the desired output, this is the desired output. The difference between the desired output and the actual output is nothing but steady state error. The difference between this difference between actual output and the desired output is nothing but steady state error. Steady state error is represented by E subscript SS. Steady state error is represented by E subscript SS, that is ESS of t. Okay, so this is a case if a transient response is exponential. This is the case if the transient response is exponential. If the transient response is oscillatory, again consider step input. Okay, this is the actual output we need. Okay, the transient response is oscillatory, let us consider. Okay, again this is up to this it is a transient response, and this is, after this again it is a steady state. Then this is total C of t. Okay, the difference between this actual output and this oscillatory output, that is desired output and actual output. This is desired output and this oscillatory output is an actual output. The difference between the desired output and the actual output is nothing but a steady state error. Okay, so this is the case if the output or the transient response is oscillatory. So this is the case if the transient response is exponential. Understood?